Here we have a tennis ball thrown off a cliff at an angle of 30 degrees from horizontal. Tennis ball hits the ground 3 seconds later. Horizontal distance 200 feet. How high was the cliff? So as usual, we will start by drawing a picture. Here's our cliff. We're launching 30 degrees above horizontal. Let's see, we have a horizontal distance of 200 feet. There's that number, and we know it hits the ground after 3 seconds. So our two choices on problems like this is the trajectory or to work in components. Since we're given information about time, a trajectory does not include time, so we will work in components. We don't know two things here. We don't know the velocity of the ball, and we don't know the height of the cliff. So those are our two unknowns. So we'll have to work through and get that. So let's work on the velocity first. We have an equation in y, so we will set a coordinate system first. Let's use the one at the base of the cliff. Okay, so everything's positive. And we have let's see, go ahead and write this. This isn't the one we want. Okay, it's not the one we want because we don't know that or that. The Vy at the bottom is not 0. This is the instant before it hits the ground. So it's got a big final velocity. Let's look at this one. Let's see, x0 plus vx0t plus 1/2 axt squared, but if we're ignoring air resistance, that of course is 0. So using this equation, we're looking for that, and we can write vx0 as v0 times the cosine of 30. Alright, so I'll put that in there. I'll have x of 200 equals 0 plus v0 cosine 30 times 3 seconds. Okay, and that's going to give me a v0. Plugging it into the calculator, let's see, 200 divided by 3 divided by cosine 30. Velocity of about 77 feet per second, 76.98. This was in feet, and this was in seconds. Okay, so now let's go back to the y direction and find the height of the cliff. So there's our equation. We know y is what we're trying to find. We've set our coordinate system. We now know that by using the component of the initial velocity, and of course we know the time and the acceleration. So y is going to be 0 plus 76.98 feet per second times the sine of theta times 3 seconds plus 1/2 minus 32.2 times 3 seconds squared. Alright, that's going to give us a y of let's see, So we got our answer times theta is 30 degrees right here. Sine 30 minus 32.2 divided by 2 times 9. I've noticed a mistake here, 3 squared. I forgot to plug my t into my equation right here. So let's go back and insert times 3. So double checking, I've got my velocity, sine 30 times 3 minus 32.2 divided by 2 times 3 squared. Okay, I got a negative number. That does not seem right. The reason why I got a negative number is because I got my y and my y0 mixed up. Okay, but I at least need to think about this. My y0 is up here. That's what I'm supposed to be finding. So let's mark this in blue. Yeah, thought it was in blue. So that's going to be y0, and that's going to be 0. And that's going to give me 29.4 feet. Okay. So I'll answer. Make sure we got correct units and answered the correct question.